Hi there, and welcome to Lesson 1.3, Linear Equations in Two Variables for Pre-Calculus. So we've been talking a little bit about equations and how equations are a relationship between two or more variables. And I know in algebra that you guys learned about equations of a line. So we're going to kind of review this for this lesson. This lesson is going to be mainly review with the exception of maybe a few new things with regards to lines. So as you remember from before, the equation of a line is y equals mx plus b. That is probably the most familiar equation that you are aware of with regards to a line, where m right here represents your slope and b is the y-intercept. The y-intercept is where it crosses the y-axis, and as we learned previously, the y-intercept can always be found by setting x equal to 0, so we're replacing x with 0 in solving for the y-intercept. So this is the most common equation of a line, but it's not the only equation of a line. It just tends to be the most useful. So let's go ahead and move on. Graphing linear equations. So when your slope is positive, meaning that, for example, let's say we had an equation that looks like y equals 2x. 2 is our slope, so our m would equal 2. This is a positive slope. This means that our equation of our line is going to be starting lower and going upward, just like this. It has an upward slope. It is increasing as you're moving to the right on the x-axis. So if we were to actually put this on a coordinate system like this, as we increase our x value, our equation of our line increases as well. Likewise, if our slope is negative, so for example, let's say we had an equation of the line y equals negative 2x, then our line is sloping downwards, meaning that again, as we're moving across our x-axis, our line is decreasing, or our y values are going down. Now we're going to go into two special types of line. So when our slope is 0, meaning that all we have is something like y equals 5. There's no x variable in this equation, just a number, and it's y equals that number. We have a horizontal line. This means that your slope was 0. Lastly, when our slope is undefined, meaning basically that you would be dividing by 0 in a case, then you're going to have a vertical line, and your equation is going to look something like x equals 1. So x equals a number, you're going to have a vertical line. So those are the 4 different possible lines that you can have. So let's go ahead and move on to the next slide here. Okay, so what do we know about the line y equals negative 5x plus 1 before we even begin sketching it? So we're not going to sit there and plot any points at this point. We're just going to take a look at this line and see what we know about it. First, it's already in the slope-intercept form of y equals mx plus b. So we can figure out information about it based on its slope and its intercept because it's already in this form. So we know, and let me go ahead and clear that off. We know that it has a negative slope. Our m right here is equal to negative 5. M equals negative 5 in this equation. So that means that the line is sloping downwards. We also know that the y-intercept is the point 0, 1. So this would be our point where it crosses the y-axis. So we actually have quite a bit of information about this line before we even plot in points to sketch it. So now we're going to have another line. What do we know about the line y equals 3 before we begin sketching it? Well, first of all, there's no x variable. So that right there tells us that our slope is equal to 0 and that this is a horizontal line. We actually know everything we need to know about this line by looking at this, because if it's a horizontal line and our slope is 0, y equals 3, that means that's where it crosses our y-axis. It's just the horizontal line. If we were to sketch this, 1, 2, 3, it's the horizontal line. going through the point 0, 3. And this would be our line right here. Okay, let's move on to the next slide now. So we've been talking about just in general if the slope was positive or negative and also the y-intercept. But now we can find the slope of the line. And again, this should be review for you from Algebra 2. But remember, your equation to find the slope is the difference of your y's divided by the difference of your x's. So y2 minus y1 divided by x2 minus x1 will always give you your slope if you have 2 points. So let's go ahead and find the slope of a line passing through the points 3, 1 and negative 2, 0. So our slope, which is represented by the variable m, equals, now we're going to follow this formula. So this is my x1, y1, and my x2, y2. Okay, so now we're just going to plug in our values. So we have 0 minus 1 over negative 2 minus 3. Simplify and reduce. We have negative 1 over negative 5. We have a negative and a negative. Those cancel. So our slope is 1/5. So we know now that we have a positive slope of 1/5 for this line. And again, this all should be review for you. So I'm moving through it pretty quickly. All right, we're going to move on to the next slide here. The point slope form of a line. So we talked about the slope-intercept form before, but sometimes we don't have the intercept, and it can make it a little bit difficult. So we might want to use the point slope form. The point slope form of a line uses the following formula. Y minus y1. Now notice this y is just your normal variable, whereas this y1 is your y coordinate of the point that you were given. So y minus y1 equals m, so this is your slope, times the quantity x minus x1. Again, this x is your variable. This is going to remain in your equation. This is your x coordinate of a point on that line. So let's find the slope-intercept form equation. Remember, that's y equals mx plus b of a line that passes through the point 1, 4. So that means 1, 4 is on the line, and it has a slope of negative 3. Okay, so we know that our point represents x1, y1. Now we're just going to plug it into this equation right here. So we have y minus y1, and in this case our y1 equals 4, so y minus 4 equals m, which our slope is negative 3, times x minus x1, and our x1 is equal to 1. So now we're going to multiply this out and distribute it, and then we're going to get y by itself. So now we have y minus 4 equals negative 3x, and then negative 3 times a negative 1 is a positive 3. Move the 4 over to get y by itself because we want it in the y equals mx plus b form. And we get the equation y equals negative 3x plus 7. So now we know that this line crosses the y-axis, or has a y-intercept of 7. We already knew that it had a slope of negative 3. So that part we already knew. But we have more information now by using this point slope formula and transforming it into the slope-intercept form. We now know that it crosses the y-axis at 7. Okay, we are almost done here. We have just a couple more slides left. Now we're going to talk about pairs of lines or multiple lines and if they have any type of relationship. So we can tell if two distinct lines are parallel to each other if their slopes are equal. So for example, let's say we have the line y equals 2x plus 3 and the line y equals 2x minus 10. We don't care about the y-intercept. All we need to know is, are their slopes the same? In here we can see that their slopes are both equal to 2. And since 2 equals 2, our slope from our first line equals our slope to the second line, these two lines are parallel to each other. We can also determine if two lines are perpendicular to each other if they are negative reciprocals of each other. So for example, if our first slope is the negative reciprocal of a second slope, then these lines are perpendicular to each other. So let's say we have the line, we're going to stay with that first line, y equals 2x plus 3. If we have the negative reciprocal, so meaning that this slope, our first slope, m1, equals 2, if we take the negative reciprocal, so first we'll put this to be 2 over 1, make the reciprocal, so now we have 1 over 2, and make it negative. If another line contains this slope, then they will be perpendicular to each other. So, if we were to take the line y equals negative 1/2 x plus 6, these two lines would be perpendicular to each other. They would intersect each other at 90-degree angles because their slopes are negative reciprocals of each other. Okay, so our final slide for the day. Yay! So this is going to be quick. We're just going to summarize everything that we kind of went through today. So one thing that we didn't so much go over is the general form of a line. Every single line can be written in the form of ax plus by plus c equals 0. So for example, like 3x plus 2y minus 5 equals 0. This is your general form of a line. You won't see it this way very often just because it's not very useful, but this is an equation of a line. And we did go over a vertical line. Remember, that is, you will have a vertical line if x equals a constant. So for example, x equals 5 would be a vertical line going through the point 5, 0. A horizontal line will be the equation y equals a constant, and specifically this will be your y-intercept. So for example, y equals 2 is a horizontal line going through the point 0, 2. We saw that the slope-intercept form, y equals mx plus b, is the most commonly used equation of a line. It gives us our most information about that line and is the most useful. But sometimes, if we don't know our intercept of a line, but we have a point and a slope, we're going to use the point-slope form. So that is it for today. I know it's a little bit of a lengthy lesson, but I hope you guys enjoyed this. See you soon. Take care. Bye-bye.